All right, I wanted to take a quick look at the second free exam problem, or free response problem. So we have two buggies, they're separated, they're going to collide with each other, one's accelerating and one's not. So the one that's not accelerating, let's write down the equation of its motion. Since it's accelerating, its equation is going to be 1/2 times 0.4 times t squared, since that's the acceleration. And since its initial speed is 0 and its starting position is 0, we can simply write its equation of motion as 0.2 t squared. Now the buggy that's traveling backwards, it's a line equation that describes it since it's moving with constant velocity. So its equation, since it's going backwards, it has a negative slope, and that's negative 0.6 t, plus its y-intercept, which is where it starts, and it starts at the 2-meter mark. So with that in mind, we're going to just basically go ahead and determine the position and the time that the cars will meet by setting these equations equal. So we're going to get 0.2 t squared equals negative 0.6 t plus 2. And so our quadratic equation is actually going to look like t squared plus 3t. You know what, let me just be clear on this. We're going to get 0.2 t squared plus 0.6 t minus 2 equals 0. Now let's divide through by 0.2 to get a simpler equation. When we do that, we're going to get t squared plus 3t minus 10 equals 0. And let's see if we can actually figure out if we can factor this. So we're going to get t plus 5 and t minus 2. So it actually appears that these buggies collide at t equals 2 seconds. I had absolutely no idea this was going to factor. Let me double check that that's right. So let's get the position that they collide at. We'll plug 2 back in here, so we're going to get x is negative 0.6 times 2 plus 2. So I'm going to get they actually collide at 0.8 meters of distance. We can actually check that right now. So 0.2 times 2 times 2, which is 4, 0.8. So yeah, it actually looks like this is a factorable equation. That's kind of cool. I never had that happen when I've done a problem like this. So that's when and where they're going to collide. Now, I'm actually not going to have you graph this in order to solve it. And I would never do that on the exam. But just so you know, if I asked you for what the shape of the graph would look like, which I wouldn't actually do, let's be clear. So we would have something moving forward as a parabola and backwards as a line. And what we would expect is this intersection would be happening at 2 seconds and 0.8 meters high. So that's it for that free response problem. And I think that pretty much wraps up the first practice exam.